Welcome to the Math Record. Today I'll be covering the ICTM Regional 2019 Division AA Freshman Sophomore 8-person. So as the name implies, it's a contest with 8 freshmen and sophomores. Um, so maybe like 4 freshmen and 4 sophomore, etc., or how combinations work, or any kind of combination which is 8 people. And then basically you have no calculators to work with this, but you have 20 minutes to solve 20 questions with your team. So it's a teamwork type of question, like contest. So I'll just take a minute to scroll down all 20 if you want to answer them. Okay. So in this video, I'm going to be answering question 8 and question 11. And then next video, I'll be answering question 17 and question 19. Okay, number 8. Determine the value of x plus y over x minus y when x squared plus y squared equals 6xy and x and y are basically positive. So what I notice is that I need to get x plus y and x minus y. So x plus y, let's get x plus y first. So I don't know what x plus y is, but I know x squared plus y squared is 6xy. So what we could do is that we could rewrite this to make it with the exponent 2. And then we just have, so all we have to do is just square this. So then when you square this, this is x squared plus y squared plus 2xy. So we have this additional 2xy. So to take that away, we'll just get x squared plus y squared. And we know this is equal to 6xy, right? And we could do the same thing for x minus y. So x squared plus y squared minus 2xy. So we had to add a 2xy to cancel that out to get x squared plus y squared on this side. So then this side is x 6xy. And then you basically just simplify this to make x plus y. So then 6 plus 2 is 8xy, and then you take the square root. And we would same thing for the minus. So that's 6 minus 2 is 4, and then take the square root, so square root 4xy. And now we could divide those two numbers together to get square root 8 divided by square root 4 is square root 2. And that's your answer for number 8. So you don't even have to look for your x and y's. All you have to do is just rewrite it in the form that you want. Okay, number 11. In base 3, k equals this long number in base 3. The leading or leftmost digit is 1, which is true because right here is 1. Determine the leading digit in the base 9 representation of k. So what we had to do is then we need to convert k to base 10, and then convert from base 10 to base 9. So, but since they're asking for the leading coefficient, as it implies right here, the leading or leftmost is 1. So the only digits that we kind of care about is the first few numbers, because everything else is kind of irrelevant. So we have k is equal to, so I'm just going to worry about the first 4, okay, because I'm going to make an example of how we're going to do this, and then there's a bunch of other digits I don't care about, and then base 3. Okay, so first we need to convert to base 10. So when you had to convert to base 10, all you have to do is just look at the number. So it would just be 2 is the constant, and then 2 is the linear for this one, and then this 2 is a quadratic, and then this 2 is a cubic. So it'll be 2 plus 2 times 3 plus 2 times 3 to the power 2, then plus 2 to the 3 to the power 3, right? And then etc. And then 1 plus 3 to the power 4, right? And then you just keep working like that. So how many terms are there? Well, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 terms, but the first term is constant. So then 20 minus 1 is 19. So you're going to raise the the leftmost digit, so 1, by power 19. So it's be 1 to 3 to the power 19. Plus, next one is 2. So 2 times 3 to the power 18. Then plus 1 times 3 to the power 17. And then plus 1 times 3 to the power 16. And then etc. You add more. So to convert to base 9, when we had to write this in the base 9 representation, this is right now is base 10. We gotta divide this number by 9 to the power of something. So some kind of value. Let's call that n. And n is the biggest exponent it could go up to that could divide this into an integer, into the smallest integer. So basically, what we have to do is we know n is 3 to the power of 2, right? So that tells us that this number on the bottom is going to be, well, the exponent here is going to be even. This is 2 times n, 3 to the power 2n, right? So basically, what we have to look at is that we see an odd here, an even, an odd, and an even. So only some are odds and some are even. So some way we need to convert this to an even. And what we could do is that we could just combine some terms together. So let's combine these two terms, and let's combine these two terms. So for this one, we could just strip out a 18, so 3 to the power 18 equals 1 times 3 plus 2. So that is the same thing as 3 to the power 18 times 5, right? And this one, we just strip out 3 to the power 16, and that'll give us 1 times 3 plus 1, and that'll give us 3 to the power 16 times 4. So this is the same thing as saying 9 to the power of 9 times 5. And this is the same thing as 9 to the power of 8 times 4, right? So when you're adding these, you could just rewrite it as 5 times 9 to the power of 9 plus 4 times 9 to the power of 8 plus etc. It doesn't really matter what the rest of the other terms are. And then we have 9 to the power of an exponent, the biggest exponent. So what's our biggest exponent? Well, it's 9. So that's why we don't have to write the rest of the terms, because any numbers that are smaller than this, as it gets smaller, as you see, uh, it's going to be, when you divide it by 9 to the power 9, and these are only 9 to the power 8, 9 to the power 7, etc., they're going to be too small and it's going to make decimals. So they don't matter at all. So these don't matter. But then we have 9 to the power 5 times 9 to the power 9 divided by 9 to the power 9. That gives us an integer as 5. So that is our leading coefficient. Well, that basically covers question 8 and question 11. In the next video, as I said, I'll be answering questions 17 and 19, and I'll just show the answers at the end for all 20 questions. Okay, well, thanks for watching, and I'll see you at the next math record.